In this video, we are going to be looking at special products with polynomials. Now, I know I have this bullet point, this note later on in all these notes here, but I want to recognize that both of these different patterns and topics that we're going to go through are considered to be shortcuts of multiplying polynomials together. The process that we learned in 6.3, which is the distributive property, and then multiplying things together and then combining like terms, 100% still applies here to everything that we are going to learn in this section, and therefore is perfectly fair game for you to use to go through and simplify and multiply these polynomials together and multiply these polynomials together here. This section is just to give us some shortcuts when we have a couple very specific types of polynomials showing up in a problem. So let's dive into each of these different groups, as it were. So our first section is working with the binomial squares pattern. And what these state is if I have two things that are adding together in a polynomial, a binomial here, and that binomial is raised to the second power, we are always going to get an outcome that is in this form here, a squared plus 2ab plus b squared. Now, a and b in this original polynomial can be anything. If we're looking down below here, it can be just a, it could be 2x squared, it could be 3ab squared, it could be the number 5, it could be anything that is multiplying together for our a or our b terms for this polynomial. And then similarly, we have a minus b all raised to the second power, and we get a very similar outcome of a squared minus 2ab plus b squared. These two things that we have here are referred to as the square of a sum, when I have things adding together, and the square of a difference if I have things that are subtracting together. And again, the entire point in using these is to recognize, hey, I've been given something in this particular form, one of these two forms here, and I can jump right into my final answer by just substituting a few things in and simplifying stuff down from there. I no longer need to use the distributive property of expanding things out and multiplying them together, though I certainly could, but I can just do this instead and jump really quickly to our final answer. Now, I will note that this is a particular pattern that, to me, is not always obvious to see. And very regularly, even when I'm going through these problems, I actually write these things out in expanded form, and then I do the distributive property, and then I jump to the final answer by going through the process from 6.3. There's absolutely nothing wrong with that, but again, just want to invite you into trying some of these patterns and these shortcuts just to see if they would work for you. If not, we can always use 6.3 instead. Now, the more important one that I think is worth knowing and memorizing, because the shortcut is going to save a lot of time, is what we refer to as a conjugate pair of binomials. So we're going to start off with the definition of this, and then we'll go through and see what this looks like. And in our examples, I'll show you what the shortcut is and the results of doing this if we multiply everything out one time. So our definition is a pair of binomials that have the same first and last term. Hence, we have these things multiplying together. They both have a at the beginning. They both have b at the very end. But one is a sum and the other is a difference. So one is adding, one is subtracting together. So, conjugates written out here. These are what we're looking for. Now, our special product of conjugates is if I have two conjugates multiplying together, then I'm going to have the first term squared subtracted by the second term squared. This is one of the three that we have that I really recommend that you have nailed down and you have memorized and you write down somewhere for yourself. Looking ahead to chapter 7, we are going to be working with factoring polynomials, essentially starting on this right side of our equal sign and breaking it down into these smaller parts. This is a very common thing that shows up with factoring, and there's a lot of shortcuts and a lot of time that are saved if we have this memorized. So of the three different shortcuts that we have, I think the special pairs with conjugates, or the conjugate pair I should say, is the main one to have memorized and the shortcut process to go through with that. Now, I will give a warning that there is absolutely no special property in any way, shape, and form for multiplying out and resulting in or factoring a squared plus b squared at all. There is absolutely nothing that exists. Maybe there's a greatest common factor that shows up once or twice in a problem. Again, that's for factoring in the Math 97 Chapter 7 material. But there is no inherent and automatic special property that gives us this as a particular product every single time. We can have this show up as a final answer, but there's no universal, when you see this, you always get to this answer. When you see this, you always get to this answer, or anything along those lines there. So let's take a look at our 4 examples that we have listed down here and see how we can apply these shortcuts to get to our final answers. With our first example, we've been given the binomial 2x squared plus 6y all raised to the second power. Now, I think it's good practice at the very beginning of these problems to try and check through and see, does this match any of the special forms that I've been given? And thankfully, it does match our first one that we have here. This is the square of a sum. I have 2 things that are adding together, and they are all being raised to the second power. So I can identify what my air quote a value is, or a term is, identify what my air quote b term is, and then I can plug that into my final form here and just simplify down to my final answer. So we'll use some slightly different colors here with this. We'll use blue here. So we have our a term, and we have our b term here. Now, looking at this, wherever an a shows up in my final answer, I'm going to substitute that in with 2x squared inside of parentheses. And wherever a b shows up in this, I'm going to substitute that with a 6y, and then I'm going to simplify my result from there. So writing this out, I should get something in this form. And notice how when we do this, we do not actually apply this second power that's showing up here at the very first step. I do think it is good practice to take one line to write everything out first, and then in our next line or two, we're going to simplify this down and get to our final answer by multiplying everything together and applying the exponent properties that we've used and seen previously in the last sections. So we'll go through and let's simplify this down and get to our final answer here. And here we have our final answer of 4x squared plus 24x squared y plus 36y squared. And we are good to go. And again, I should note as we go through these problems, if you are not able to see that this is the square of a sum, you could write this out and expand it into an alternative form. Just put a quick preview of that. You could rewrite this thing instead to be 2x squared plus 6y times 2x squared plus 6y, like we did in 6.3, and then we can work this down and get to the exact same final answer from there, just as an alternative. Our second example is giving us the expression 3ab squared minus 5, all raised to the second power. And again, we're going to take a look at which of the original starting forms that we are working with. And in this case, we have the square of a difference. I have 2 things that are subtracting together, and I'm squaring them in my original problem. So I can think of, again, having my air quote A and air quote B terms, and I can identify those and then plug those into the fully simplified form and then simplify things out from there. So we have our, again, I put the air quotes around this A term, and we have our B term here because there's not really an official name for them in that regard, but we'll use this here. I'm going to plug those in, this form that we have written out here. Again, I'm not solving anything, I'm not multiplying anything out, I'm just substituting these things in right in here first. And now that I have this all set up and substituted in, I can simplify this down using PEMDAS and the order of operations. We'll go ahead and go through and do that now. And we get to our final answer right here. We should be getting 9a squared b to the fourth minus 30ab squared plus 25. And make sure as you are going through this process, you are referencing the previous sections. A lot of this is the 9.3 material, but we do use the, not 9.3, 6.3 material. And we're also using the exponent properties we learned from 6.2 to work with the exponents and determine how they combine together and simplify down. Looking at example 3, we have the product of 9x to the third power minus 4y to the second power times 9x to the third plus 4y to the second power. We therefore have a conjugate pair of binomials. The first two terms are the exact same, the last two terms are the exact same, and the signs that separate them are opposites of one another. One is a positive and the other is a negative. The order that these are written in, which one's positive and which one's negative first, really doesn't matter as long as they are considered to be conjugates of one another. So like we did with our first two examples, let's go ahead and denote for ourselves which terms are our air quote A terms, which is going to be the 9x to the third powers, and which ones are going to be our B terms, which in this case are going to be the 4y squareds here. So now that we have these written out for ourselves and labeled, we can go ahead and substitute these in for A and B in our final answer. We're then going to fully simplify that down, and then we will get to our final answer in 2, maybe 3 lines of work. And here we get to our final answer of 81x to the sixth minus 16y to the fourth. A lot less steps and a lot faster than having to go through the full distributive property with these particular types of problems. In our fourth and final example, we're looking at yet another instance where we have a conjugate pair of binomials showing up here. We're starting off with 11m to the third n to the second plus 2mn, and that's all multiplying with 11m to the third n to the second minus 2mn. Don't let the number of things that are multiplying together in each of these individual terms sway you. We had 2 things multiplying together in example 3. Now we have 3 things multiplying, the coefficient, the m, and the n's. It isn't going to change our process. I just wanted to show these examples to say, hey, things can look gross. We're still going to go right back to our process and use that to get to our final answer. So I am once again going to identify what's my, and I'm using air quotes with this, A terms. That's going to be the first things in each of these sets of parentheses. We'll look at what's the B terms going to be, and that's the second things that we have in these sets of parentheses. We are once again noticing that we have conjugates here. One of them has a positive sign in the middle, the other has the negative sign in the middle. Doesn't matter which one has which, but one is positive and one is negative. That's the requirement. So like we did with example 3 and our previous ones to that, we are going to be plugging these things in for A and B in this part here at the end, and we're going to solve this out and simplify for our final answer. And we get to our final answer of 121m to the sixth n to the fourth minus 4m squared n squared. As a quick recap of the material we covered in this video, we had our shortcut forms of special products. We had the binomial square pattern showing up here, the square of a sum and the square of a difference, and what those results are always going to show up as. And then we had the, I think, all-in-purpose one, or the most important one, is the conjugate pair of binomials, where the first terms are the same, the second terms are the same, but the middle signs are opposites. One's a positive, one's a negative. And then we have the final answer form that shows up with this. I think it's the most beneficial of these three to know because I think it saves us the most time getting to our final answer. But with all of this, again, recognizing these are shortcuts and they are optional. You can use everything that we went through in 6.3 to expand and multiply these things out using the distributive property, and you will get to the exact same final answers there that you would with these shortcuts here. We then went through our 4 examples written in down here and our processes with those. Again, I would recommend with all of those, get in the habit of substituting things into the final answer form and then going through and calculating what the answers are. Very commonly, people will correctly identify the final answer form, but they'll make an error because they forget to bring a negative in or something to that effect to get to the final answer. So we'll scroll down and take a look at some extra practice problems. If you would like to take the opportunity to try some of these for yourself, I'd recommend pausing the video right here. Remember to identify which of the forms we are starting in. It's got to be one of those 3. Identify that and then follow through with the process that we did to get to our final answers. We have our answer key right down here. Hopefully you're getting the same things as what's listed down here. It shouldn't matter if we've been given fractions or not. We're still going to use the same process, and we're still going to be multiplying everything together and adding and subtracting things as necessary. But this is everything for our 6.4 material.